Can everyone hear me? Hi, Boom. Hi. It's kind of crazy standing up here and everyone's sitting down there, but I'm kind of sitting with you all, really. Oh, who's having a good boom? Yeah. Who's having a good boom? Yeah. Who's ready to get fractalicious? Something like that. No, my name's Jamie. I'm from the UK and I have a background in physics that I've diverged from into the worlds of art and consciousness and here, there and everywhere, and my work is to merge the analytical and the intuitive, or spirit and science, or however we want to say it, just to find a harmony between the hemispheres and the mind. And I've come up with a few different ways of doing it, and being invited to Boom has given me the opportunity to try a few different things out. We've only got an hour, so we will see where it flows and how deep we go down the rabbit hole to Wonderland. Sound good? Sound good? Okay, well, because I'm going to be talking about mind stuff, and we don't want to get the mind too carried away and get its iffy grip stuck in the dogmas, so I think it's important for us to enter that space of receptivity so that all of that yummy, sciencey, knowledgey stuff can flow straight from the brain into the heart. So I just invite each and every one of you to join me, and I need it too. Take a deep inhale and a relaxing and again. One more time. Relaxing the gaze, relaxing the mind, relaxing the attention, and inhale. Okay. So, let's play. This will work. Yes! It's all quite pixelated, I don't know what it looks like from the back. The goddess, the feminine, is what we're here for. We're here to remember, to reimagine, to redream, to revision who she is and what she means to us. And a deep part of my work is studying physics through mythology, looking backwards in time and seeing how other people related to the way we describe reality. And you end up in a network of cultural myths that spans eons, and you end up finding self-similar patterns. And one of those patterns that I spotted earlier on was this story of creation from chaos, this mythological story. And normally, you know, there's cultures all over, every culture pretty much on the planet has it, whether it's in the East or the West, whether it's in Africa or Asia or the Americas. You end up with this the story of the creation from chaos. And what's interesting is that the more later myths of that are this kind of image of a cultural hero deity, storm hero like Marduk or George, St. George, slaying this chaos monster. And this isn't the original myth. This is a myth that came about 3,000 years ago when we started inventing lots of sky gods who decided to take over lots of the goddesses' attributes. And so this type of creation from chaos isn't the one that I want to talk about today, because I don't think it's serving us anymore. So I want to reimagine chaos and reimagine it through the lens of physics and see where that goes. So, I mean, chaos has been given this terrible reputation in society. We say, oh, it's all gone to chaos. And as if, you know, there's something disastrous has happened. Or yeah, we say, oh, it'd be chaos if we did that. The truth is, you know, we had these chaos goddesses at the heart of our pantheons for eons, and backwards before records even began. This is just an image of a drawing of Inanna that I drew, who I relate to in this form. And a lot of these goddesses were related to serpent worship and the weaving, ever-changing, ever-flowing, and those symbols have been changed through time. So let's reimagine what they are and come to a place where we can dance with chaos rather than trying to slay it. So chaos is essential. That's the bottom line. Your brain, if you scan it with an EEG scanner, has a signal. Now it turns out that behind that signal is a background signal of chaotic noise, and it's been shown that if that signal becomes too periodic, you actually descend into an epileptic fit. So without the non-chaotic mind is actually the epileptic mind. So we physically need chaos, as Nietzsche perfectly wrapped up. You must have chaos within you to give birth to a dancing star. And today's great creation myth, that one of science, that's the wrong slide. This one, the Big Bang, is fairly similar to all of those kind of cultural stories of creation from chaos. You end up with this primordial universe, which is just like that primordial fertile soup of the waters of the womb of the goddess, and everything is half existing in this chaotic neutrino soup of energy that's popping in and out of existence. And there's like a semi quantum plasma gluon soup. It's highly relativistic and completely chaotic, and from that you end up with, this is our myth, you end up with about 400 years later you get the first atoms forming, and then about 400 million years after that the first stars forming. We start to see some amount of order arising in the dance of chaos, and yonder from there, 13.7 billion years later, we find ourselves here on this beautiful land, sitting here at the lake, enjoying wonderful treats. But the dance between order and chaos continues. And what's beautiful about it is the way the two are nested in each other. You see these large voids of kind of space, and then huge amounts of order and space and order and space and order. We'll go into that a little bit more in a sec. And I think it's up to us to kind of I'm going to just go back 2 slides, to reimagine chaos for ourselves, and that's what I'm doing. So I believe actually that the universe was born from a cosmic teapot from which the primordial waters flowed. And actually, if you look southeast as the sun sets, you'll see Sagittarius rising from here, and Sagittarius is in the shape of a teapot, and it's pouring out the Milky Way. It's how it got there. Milky Way was actually poured out of a teapot. Onwards to physics and what they've got to say about all this. So, chaos theory. Who's heard of chaos theory? Yes, actually, quite a lot of people. So, chaos theory. Amazing, really. It happened in the 1960s, this kind of rebirth of the new science, the next science after the quantum revolution. Effectively, it shattered the golden era, and the golden era was this idea that we could perfectly find mathematical solutions to everything. The problem with that is it's completely not true, because all you need, so here's a really simple example. If I have the Earth and the Moon, I can tell you the force between them and the orbit of the Moon around the Earth to a very high degree of accuracy. However, if I add just one more moon to that system, all of the forces feed back onto each other, and the equation is completely unsolvable. We have to use a computer to solve it, and that's what happened in the 60s. And when we started doing that, we started to find these incredible patterns hidden inside very basic mathematics. This is the Lorentz butterfly. It's a good image of the butterfly effect, which is that idea that a butterfly's wings here could cause, a storm or a typhoon somewhere else in the world. And that's how physics works. It's extremely sensitive to initial conditions. It's just waiting. It's ultimately receptive to our interaction, and it changes. Its changes propagate exponentially from there. And we're actually living in a universe that's filled with chaos. The orbits of the planets might seem pretty stable on the time span of a human being, but they're actually completely chaotic orbits, and we can't predict them for large periods of time. So the butterfly effect, beautiful, butterfly transformation, and so forward. What is amazing about all this chaos stuff is the relationship between it and order. Benoit Mandelbrot was a bit of a mathematical shaman who came across some pretty startling things. One thing he was interested in studying was signals in electrical signals. And what he found in studying these signals is that they always had an amount of chaos in them, an amount of noise. And of course, as a signal engineer, what you want to do is get rid of that noise. And what he showed is that if you have a perfectly seemingly good signal, like if this white represents a pure tone signal, when you analyze it, you'll actually end up with a region that's chaotic. And what he showed is that if you take that signal with a chaotic region, that's the black bit, and you isolate just the bit that's good, the bit that's a pure tone like this, and you cut it away from that signal, what was a pure tone will now contain an amount of chaos. And then you can do the same, and each time you do it, and you can do the same with the chaos as well. And literally by the moment that you take a signal and take out the bit that is perfectly ordered, you end up with noise in that signal. And what he did is mathematically showed that that's always the case. And so you get this beautiful nesting and self-similarity. Here's a good quote. It turns out that an eerie type of chaos lurks just behind a facade of order, and yet deep inside the chaos lurks an even eerier type of order. So order and chaos can emerge from each other, which is a beautiful representation of wholeness, of yin and yang, of masculine and feminine, of order and chaos coming together. The Tao that can't be spoken isn't the eternal Tao. Its dualistic elements can be rather pretty, and that's what I hope to show you in this brief little talk. So, self-similarity. Chaos leads to nesting, leads to shapes inside shapes inside shapes. And these have a special name, and they're called fractals, and that's why it's the physics of fractal consciousness, and we'll get onto consciousness in a wee bit. This is a triangle with triangles inside triangles inside triangles inside triangles inside triangles. It's a really basic fractal. You can do all sorts of different types of nesting. So if you start with a triangle like this, and instead of putting them inside each other, you attach them to the outside. So it's Star of David, or Seal of Solomon, and then you go again, and again, and again, and even again. You can obviously do this theoretically to infinity. What's amazing that when you do that is that what's happening each time we add an extra layer of detail to this form is that, the area of the form is getting slightly bigger, but so is the edge of it, the perimeter. But what's amazing is when you take this to infinity, the area converges to a very finite number, so we know the area of it, but the actual edge of it goes to infinity. So it means that this type of fractal geometry is not only the marriage between order and chaos, but the marriage between the infinite and the finite, and put perfectly in the words of, William Blake: to see a world in a grain of sand, and heaven in a wild flower, hold infinity in the palm of your hand, and eternity in an hour. That's what fractals are showing us, and we see them all around us in nature. So that kind of undefined length going to infinity is exactly what we see, say, when you look at a coastline. We could use the lake, for example. If we were to look at a zoomed out picture of the lake and to try and measure the edge of it, you would get a certain number if you used, a zoomed out view. And each time you zoomed in, you'd get more and more detail. So you would end up with little bays and nooks, and then in those bays and nooks there would be nooks and crannies, and in those nooks and crannies, and what you'll find is that the length of that lake, the edge of it, has a completely undefined length. It's a marriage between the infinite and the finite. Fractal. Are we good? Is this fun? Yeah? Cool. Actually, I'm going to keep the time with me, because I have a habit of... So, who's seen the Mandelbrot set before? This is amazing. Again, another discovery of Mandelbrot. We could only realize this form when we invented the computer. It actually is based on an extremely simple equation. It doesn't matter if we don't understand what that equation means. It's just that it's very simple. It's just something equals something squared plus 1. But the difference between that and a normal equation is we take the answer to that equation and then we plug it back in as a question. We keep doing that. It's called recursion or iteration. And we do that over a field of points, and what we end up with is a form that has infinite complexity. It's absolutely phenomenal. So the Mandelbrot set, I think I've got a video. Yes. Okay. this is a piece of the Mandelbrot set, and what you can already see is that inside it, as we zoom in, there are smaller Mandelbrot sets, but none of them are identical to the original one. They're all slightly different. They all have their own complexity to it. The Mandelbrot set is actually a one-dimensional line that's folded onto itself so infinitely much that it perfectly fills two-dimensional space. And it is a true figure of wholeness, because each individual piece of this form contains the whole image, just like our universe. Each one of us contains the whole universe within us. And what this is really describing is the edge between order and chaos, the betwixt and the between, that sweet marriage of the divine masculine and the divine feminine, merging out of unity, the Tao, however you want to call it, source, breaking apart into duality, and from there having a relationship which is complexity, which is the marriage between them all. And from there we end up with a myriad of things, of multiplicity. And that's the emergence of form, but you can't have the emergence of form without the two of those dancing together. And this is something that quite evidently cultures all around the world have realised for a long time. I mean, this is an Islamic mosque, is very fractal in nature, or a Shipibo pattern, nesting self-similar forms, or a Buddhist mandala with the gates progressively embedded inside one another, going deeper and deeper and deeper. Celtic, the Book of Kells. I don't know how clear it is in the screen, but actually it's so incredibly ornate that these contain somewhat of a similar image of the whole thing. A really good example is in Ethiopia, where they have these crosses, these keys, and you can literally perform an iterative kind of investigation to find how they chose these shapes. They're literally fractal. And there's a great guy, he's an anthropologist, he has an amazing TED talk, and he talks all about this on TED. And his research was on a specific tribe in Africa called the Bala tribe, the Bala people. And this is how they build their villages. They have a central village, and then all of their houses are the nooks around the village. And then at the farthest end they have the kind of the chief home, and then there's the Holy of Holies, the temple, in the centre. And what's amazing is even the way that they put the bricks together form almost small little villages. And inside each village, inside each house in the village, there is a central altar. And inside that which looks like the village, and inside that central altar there's an even smaller, and that's the place of the gods, that's where they live, inside that little place. So I mean the idea is that this is something that is deeply embedded in our ancestry, this type of self-similar fractal form. However, we've kind of lost the plot a little bit. Somewhere along the line, given all of this complexity, we appear to be forgetting. I think this is a big part. That slaying of the serpent is a very physical thing, in the sense of the way that we actually just override our basic common sense with trying to overly order and overly structure the patterns that we create. And so I'm actually, as well as a physicist, a fractal artist. So I use my computer to explore the depths of chaos and surf around until I find a pattern that starts to resonate with me, and then I start to tune into that mathematical form, and then I start to bring in colours, and I end up with these beautiful discoveries. And they really are discoveries, because I don't create these are just embedded in mathematics in the same way that Mount Everest is embedded in the earth when you go and discover it. They're just there, just waiting to be found. And what's amazing is that because these are mathematical equations, one need only make that equation time dependent, and the whole thing starts to breathe and come to life. And there's something extremely organic about that. And at the end of the talk I'll be doing a a little bit more. Here's another one. Yeah, the possibilities are endless. And yeah, I sense they tell us something, these forms. They do something in here, and so at the end of the talk I'm going to do a live visual set to music with this type of geometry, so we can really enter the void rather than talking about it. These forms are painted all over the planet. They're everywhere. Everywhere we look, there's fractals. I mean, this is a Romanesque broccoli. Who's eating one of these? Amazing. If you do, you've got to have reverence for this vegetable. It's literally a spiral covered in spirals. And those spirals are covered in spirals. And if you look really closely, you see there's even little spirals on them, spirals that are on spirals. Madness. I remember being a boy and just looking, you look at a fern, and the way you look at a fern, and each piece of the fern has got a little fern inside it, and then that fern, it's just amazing, isn't it? And so you get the same thing with spirals, right? Spirals are self-similar across universal orders of magnitude, from the path of an electron in a magnetic field, which is a spiral, to galaxies and storm systems and the way that shells grow. There's something this is telling us about the way that nature wants to reveal itself. And the same thing goes to say with branching forms. So where like your lungs, it's this kind of branching network, or it's like a mycelial network, like the way mushroom grows and weaves through the soil, or lightning, so many other things, electricity, river deltas, the tributaries in our bloodstreams. We see the same pattern on many orders of magnitude, and it connects orders of magnitude. It tells us something about wholeness. I believe it tells us something, what I'd almost call a meta-geometry, something beyond geometry is there. Like the geometry is the manifest form, and then behind it there is this kind of hidden world, which is like the manifest form is also almost like the masculine expression, and behind it is this untouchable archetypal force that just wants to come through, and it comes through in every way that it can, and in this case it's trying to connect things, it's connectivity, it's to branch and link things up like the internet. So yeah, I mean, nature's pretty fractal, I'm sure we can agree. Time's pretty fractal too, actually. Yeah, I mean, when you think about it, you came out of someone else. So if you were to imagine plotting a four-dimensional kind of space-time version of humanity, you would actually see the people kind of coming out of people, coming out of people, coming out of people, coming out of people, and make this great big tree in space-time. As if we connect all of the dots ancestrally, we are really one giant organism that's almost just like a tree. So and also cultures have recognised that time's fractal all along. We have this idea of eternal return and deja vu and samsara, and we see these historical coincidences of repeating patterns through time, history repeats itself, so forward and so forward. I mean, how fractal is the universe is a big question. How fractal is the universe? Well, it turns out that actually the stars are distributed in a fractal formation. And for instance, if we were to just trust the Big Bang model, basically the Big Bang model is this idea that you've got this rapid expansion and then you've got this kind of contraction through gravity, and the two are wrestling each other through time. And so because we know the age of the universe, we're according to the Big Bang Theory about 13.7 billion years, we know how much structure there should be in the universe. We know the maximum size an object should be. And it turns out that there's orders of structure that are billions of light years across, and we should only really be seeing structure about 30 million light years across. This is something called the Sloan Great Wall, which is a wall of superstar cluster galaxies that spans across a good portion of the night sky, but we can't see it with our visible eyes. It's huge, and it's fractal in geometry. And so, yeah, the universe is quite fractal. Has anyone seen this? Oh, there we go. Back up. Oh, yes. That's funny. I did a presentation and it didn't want to show this slide before, actually. It just removed it from my presentation. Something that the universe says the trickster. Has anyone seen this before? Does anyone know what it is? Is it in your eye? Well, it's not when it goes blank. No? Any other ideas? Brain cells. No, it's not. It's actually the distribution of dark matter in the universe. That's what the universe looks like. We can't see dark matter. Yeah, so the universe looks like that. Like, we can't see dark matter, but we can measure the way it bends space-time, because it still has mass. And also we can do computer simulations, and that was a picture done in the year 2000 by the Millennium Survey of the Heavens, the largest study of the heavens. And it literally looks like a giant brain, and those kind of centres that look like the central synapses are super galaxy clusters where there's lots of matter, and then the filaments, the kind of thin threads between them, are seemingly empty space, but they're actually threads of dark matter. And we don't know what dark matter is. You know, 96% of, well, if you include dark energy as well, 96% of the universe is that stuff. And so, yeah, it leaves a lot of questions. So this universe that seems so separated is actually more like a giant mind. I think it's a big clue. So, yeah, so it's a big clue to maybe the universe is conscious, or maybe let's just look at, you know, is consciousness fractal in nature? Do we experience a relationship, or is there like a symmetry between, is there a symmetry between the outer world and the inner world? Like the Hermetic, as above, so below. But when we think about the universe, it's definitely got this nesting pattern going on, like I said, I keep saying it, you know, so you've got like atoms, which are made of quarks, and they're made of potentially strings, or whatever theory you would like to appeal to. And then those atoms group together to make molecules, which group together to make, you know, in organic life we'll make organelles. They're the kind of organs for a cell, and those cells, those organelles will group together to make cells, and those cells will make tissue, which will make organs, which will make organ systems, which will make an organism. And then you get enough organisms together and you've got a community, and then we've got an ecosystem, and then, you know, we've got a great big lovely beautiful planet Mama Gaia to look after, and you can keep going from there, and there's that self-similarity nesting thing going on. I'm not too much into the idea of seeing that as a hierarchy. I think there's a really important distinction. We're fed a hierarchy in school, this idea that it's a hierarchy of authority that we've applied to life and to reality itself. I don't think it's just, because just like in the Mandelbrot set, where each piece contains the whole, you can't create a hierarchy out of that. You can't take a smaller Mandelbrot set and say that Mandelbrot set's smaller, therefore it's in, you know, it's in some way lower in the chain, because that Mandelbrot set actually, even though it's smaller, contains as much information as the whole thing, because they both contain infinitely much information. And so in the same way that each piece contains the whole there, we all contain the whole universe inside ourselves, and so does each electron. That's why when we have a particle accelerator like at CERN in Switzerland, we can take two particles, smash them together, measure the energy, and extrapolate that about the whole entire universe. You know, what we discover there, we say that applies to everything in the universe, and the reason we do that is because each piece contains the whole. And that's a journey that you can go a long way down to the holographic universe and so forth, which, by the way, is becoming the currently accepted paradigm in theoretical physics today. It really is. Not into that rabbit hole today. So yeah, what type of self-similarity is there between what I'm describing outside and the things that we describe inside? So this type of complexity in fractal nature is I'm saying a relationship between two things, like a dynamic tension between order and chaos, between the finite and the infinite, between the masculine and the feminine, between, you know, whatever forces we want to describe them as. And that's exactly, you know, what the entire universe is like. It's this world of duality. We've got tea and cake and up and down and the rest of it. And the same in our minds too. We're this walking heap of dynamic tension. And, you know, if we ever take the moment to really sit and focus on that tension, it becomes almost like this hall of mirrors. The deeper and deeper layers of consciousness, deeper and deeper layers, subtle layers, like the scriptures talk about in all of these great spiritual cultures, of being able to go deeper and deeper and deeper and deeper into the moment, and trusting that each individual experience of that will reveal, by returning to it, the whole form. And so in each one of us, we are like, in our minds, this cosmic hall of mirrors. It's almost like the mind is literally a reflection of the outside world. Well, in fact it is, because everything that we experience is actually reflected in our minds. When we hear a signal, like you're hearing my voice now, your mind recreates the sound of my voice inside your brain as the same pattern that's travelling between me and the air between you. You actually create a self-representative form of the world around you. There's cells inside your brain that literally grid out your position in space-time. And people have tried to isolate those cells from the senses by basically taking away sight and so forth. And they're still able to operate and to form these lattices, these patterns inside the head. The outer world is literally within us, in a, I would say, not like a hierarchy, but like a holarchy. Like a holarchy. We can trying to imagine what that means. I think that we can really use this dynamic tension to ground this in something really useful. We can say in physics you have this kind of very strict causality, which is kind of telling us what to do. It's like the cosmic billiard ball table, which is the deterministic Newtonian universe that we're all spoon-fed at school. And then on the other side of that, quantum mechanics reveals a universe of pure randomness. And so what's the marriage between those two things? What complexity does causality, does determinism, and pure randomness breed? I feel in my own personal life that it breeds something like synchronicity. Who here experiences meaningful coincidences? Yay! Woo! For meaningful coincidence. I'm sure quite a lot of people have had a bunch of synchronicities already. I think there's two basic ingredients to having synchronicity, to having an experience that is more connected, which is basically this fertile soil of chaos, which is allowing yourself to go with the flow, to be out there surrendering to what happens whenever it happens, and simultaneously that order, but not the order that's slaying the chaos, but that order that's supporting it and holding her like a beautiful goddess. So it's like the garden trellis is the way I picture it, that structure, that Euclidean repeating form through which the garden peas can grow. And so by having structure in our lives, we can really help to optimize the chaos so she can be most abundant in our lives and breed complexity. So I mean, who is that? Yeah, Jung had a beautiful quote about this. He said, the cycle, this is kind of, I think this is the bottom line of Jung right here. The psychological rule says that when an inner situation is not made conscious, it happens outside as fate. That is to say, when the individual remains undivided and does not become conscious of his inner opposite, the world must necessarily act out the conflict and be torn into opposing hearts. Bravo. So like, let's dance with chaos, let's trust in the chaos, because it's trying to show us something in ourselves when it comes through. It's a moment of opportunity, and it's a moment of opportunity for science, and it's revealing a new way of being in science too. So this is something that, how we live for time. loads of time. This idea that there's a real connection between the inner world and the outer world is something that the great physicists seem to all be kind of, so there was these great physicists of the last century that kind of reformulated all the ideas of the Newtonian world of determinism, and they all had some pretty interesting things to say about it. For instance, the grandfather of quantum theory, Max Planck, who literally laid the first stones down for quantum theory, said, "Mind is the matrix of all matter." And he's one of the greatest physicists of all time. And some of the reasons that he was saying this is because it's what physics pertains to. I mean, for a bottom line in physics today, we can't talk about a universe without talking about an observable universe. But in relativity, we have to define ourselves relative to something else, and in quantum mechanics, the whole thing gets blown out the water, and literally there isn't a universe without an observer. I'd just like to take a moment to really hone in what modern physics is showing us about our place in the universe today. So, mind is the matrix of all matter. Everything we do affects everything else in the universe. Just in the same way that with my fractal drawings, as I'm building them, if I change just one tiny thing, the whole pattern changes. The same with the Mandelbrot set. If you just change that equation just slightly, the whole thing changes. That's how chaos theory was discovered, was by one of the first computers that was able to basically do basic modeling, had a very primitive program built into it that was meant to map out weather patterns, and it effectively had 10 variables in it. So it's very simple. In comparison, like a modern weather program will have trillions of variables. It's a very simple program, and the idea was that you run the program, and then it gives you a bunch of numbers at the other end, and those numbers pertain to atmospheric pressure and temperature or something like that. And the guy running the machine, Edward Lorenz, one day decided that that's it. He'd made an error, and he needed to rerun, and he was halfway through. I mean, this thing, you'd have to press play, and it was a bunch of tapes that would spin. Leave it for a couple of days, come back to it, or at least a few hours. And he realised he'd made a mistake, and rather than wanting to rerun the whole program, he got the printout and decided, well, I'll just run it from there and put those numbers back in. The thing was that those numbers were rounded to the 4th decimal place, and he thought, well, that won't make any difference, I'll just get, that rounding. And what he found is that actually by that tiny difference, the entire pattern of weather in his little software program is entirely different. And this is exactly how reality behaves. So here's a thought experiment for you. The idea of this thought experiment, this was created by Michael Berry in Bristol University. It's one of my favourite thought experiments. The idea is to show how sensitive the universe is. This is mind-boggling. So if you want to show how sensitive the universe is, you need to show that if you make a small change, something's going to happen. So his inquiry was, what's the smallest possible change we could make to the reality we live in? Well, what we need to do in that case is probably, actually to begin the experiment, what he said is, if we take a box of oxygen molecules like this, and they're just kind of floating around, free-flowing in there, then that will be our test subject, this box of oxygen molecules, and that's what we need to make a small change on. So what he does is he kind of, in the thought experiment, you imagine this box of molecules, and because you're the goddess or the god of this experiment, you can follow it and trace every single particle in the box, and you map them out. And then because it's a thought experiment again, you can do whatever you want. At the end of the experiment, you press stop, you press rewind, you go back to the beginning, and then you go to the edge of the visible universe, which is 13.7 billion light years away. Actually, no, it's further away than that because the universe is expanding, accelerating, about 40 billion light years away. And you take the smallest particle that we know of, which is the electron, which we consider to be a point particle just because we can't look smaller than it, which is about 2,000 times lighter than a single proton. So it's a tiny little thing. And we secretly place it at the edge of the universe, and we decide to ignore all of the forces apart from the weakest one, which is gravity, which is by far the weakest force. So we're talking about the tiniest particle known to modern physics, at the largest distance known to modern physics, using the weakest possible force. And if you place that electron there, and you press play, what you'll find is, if you were following a single oxygen molecule in that box, within about 50 collisions, the uncertainty would be so great that its position, its direction could be within 360 degrees of where it was going last time. So you lose all mapping of the territory. That's how sensitive reality is. The tiniest touch sends ripples out to the edges of the universe. So everything we do here, everything we don't do here, affects the entire universe. More than that, the universe is really sensitive, like that. And that's a completely classical, what we mean by classical is like it's a completely deterministic description of reality. But when we go quantum, things get even more wacky, because in the quantum world, everything is extraordinarily connected. Because in the quantum world, two particles might be actually in some way the same particle. So for instance, it's very possible, it happens all the time, to prepare two particles so that their properties are what's called entangled. So the quantum vacuum is this foaming space of, it's the dancing Shiva breathing particles in and out of existence, popping and flowing and weaving. It's alive with a background field of energy. That's what physicists, quantum physicists study, quantum field physicists in particular. Amazingly enough, when particles pop into existence, they might do so in a certain way that, for instance, they might have what's called property, what's called spin, which is basically just like we imagine spin to be. So that one of the particles might have this type of spin, and the other one might have this type of spin. The laws of physics are so perfectly accounted for that given one type of spin, we know that the other one must have the other one. And what's really awesome is that actually, before you measure what type of spin those particles have, they don't have either of them. They're both. So you can take two particles, take them to the edge of the universe, measure one of them, and simultaneously the other one will kind of pop into existence to form the mirror image of the other one. Because in actual fact, the information between them isn't inside the particles, it's spread out like a hologram across the two of them. What's amazing is that things can become, and they do become, entangled in quantum theory. As particle systems interact, they get more and more and more entangled with each other. And it's impossible to measure actually how entangled they are. All we know is that they're extremely entangled. So the universe is a little bit like molasses, that sticky stuff, or honey, and feathers. If you've got a big ball of feathers and covered it in honey, and you go touch it, and you try and take a feather out of the honey, it all kind of just gets more and more gloopy and globbed and glibbed and glabbed together, until the point where everything is all connected. And it literally is that way. There's particles, there's atoms in us that are entangled with atoms in other parts of the universe all over the place. So, and those entanglements happen instantaneously. They're not bound by the speed of light. So we're living in an extremely, extremely beautifully complex, sensitive, ornate, and entangled universe. And I'm grateful for that real order of physics. It's so specific, so exact, the way we don't fall through the floor and all that. But it leaves the perfect amount of space and spaciousness for that undefinable, ineffable expression that lies behind it to come through. And so I guess I've been talking a lot about it in its manifest form, And what I would like to do is show it to you, maybe in its more experiential form. So I prepared some music by some artists, not my music, but I prepared some visuals to take us all on a journey together. It's my first time doing this. My art and my physics have been combining more and more and more and more and more over the years, and the next progression of my work is to really to create spaces where we can do less of the talking and more of the journeying down the rabbit hole. So this is like prototype. Hopefully the cosmic fool is not going to play around with me and make the screen flicker or something. If it does, just laugh along. But we'll give it a go, and let's go to Wonderland. So I just invite everyone, just while I'm setting up, to take a moment to centre themselves. I think that's how you'll get the best experience from this.
The beginning, but I live in a small room near there. I wake to light each moment. I find the cracks and sing daily expansion songs to their sleeping ambition. What I know is alive. What I know is green and fearless and unmapped. I have given birth to myself with each year's revolution, offering to a larger nourishment, not meant for the stockpile, the shadowed storehouses of unharvest. This fertile form wants only to be put to use, planted in rich soil, watered, weeded, one of a vast and diverse permaculture. Each moment wakes me to light, shedding protective layers so light can breed life. Carried in bird beaks, on insect wings, in the labyrinths of wind. Any earth is home and worth knowing. I love best any hands that cradle me sacred. I love equally the wild scatter and the even rose. I sing equally the sowing song, the reaping song, and the song of perfect rain. I am the joyful offering to any true need. And when I am done being seed, I will laugh, rename myself the world, and go on singing this offering song. Doesn't firelight, all these falling leaves, golden tide. It is the canicula carries in her belly the most precious gold. She is the vessel which must be broken. A chameleon from chaos, wherein all secrets are hidden. The central water, the bride. The chameleon. All these falling leaves, golden light. I am just a child, watching everything unfold into golden light, the central water, wherein all secrets are hidden. To sprout wings, the matrix must be open. All these falling leaves. The bride. The matrix will be open. It is the canicula carries in her belly the most precious gold. She is the vessel which must be broken. The central water, bride. All these falling leaves, golden tide.
Thank you. Through Boom Spirit, we get a question and answer session. And before that, yeah, I'd just like to say huge thank you. I mean, for witnessing that. That was definitely a debut moment for me, and I really appreciated everyone's presence.
Hiya, thank you so much for a great talk. I just wanted to ask if you could say a little bit about your formal education, and then how you sort of moved from that, because you talked a few times about things being sort of spoon-fed at school. When did you sort of have the moment where you sort of started to explore things in an alternative way?
Well, yeah, I studied physics at Imperial in London, very rigid kind of institution. But the seed for wanting something wider was there all along, you know. That's what took me to physics in the first place. It's like, what is this? I was just ultimately curious. And I just felt like it was going to come, and it never quite came. And they were giving it, they just weren't giving it in the form that I expected to receive it, so I knew I needed to translate it. And so I ran actually, you know, a million miles from academia at the end of my degree and moved to Canada, and that's where I've been for the last few years. But actually I've been studying at the Schumacher College in Devon, which is this, they run a master's there for holistic science. It's kind of the only place in the world they do it. So I'm approaching the end of my course there, and will be handing in, well, be facilitating my dissertation at the end of the month. In fact, the next speaker is a good friend of mine at the college. So yeah, a little bit more of the Schumacher buzz in the evening. Does that answer your question?
Yep, that's absolutely brilliant.
Cool.
Thank you.
First of all, thank you for the talk. It was amazing. And yeah, I just wanted to know where can we follow you? I mean, you have a webpage or something?
Yeah, I have a website. It's in thoroughly need of an update because I've been studying and not focusing on it. I have a whole bunch of material to go on. So yeah, I think that I have business cards, but I also have some of my artwork in the form of art prints, art cards, that I'll be selling at the end, and so you can come up and just take a business card or have an art card or a sticker or something. But it's metamorphics. You can't put it in the most worst spot ever. It's METTAMORP. It's like metamorphosis, but meta with two T's is Pauli for love and kindness, and then physics on the end. So if you come to me, I'll give you a thingy, and yeah. And there's a space page where I put things on. Yeah.
Hello there. So fractals, they're all very visual and physical, but do you think fractals can apply to things such as sound or radio waves or other parts of the electromagnetic spectrum?
Absolutely, totally. Yeah, this is just one form. You know, we're talking about a very general thing. In some of my longer workshops, I apply it to consciousness itself, in the sense that, yeah, there is, you know, when I mentioned that the pattern behind the geometry isn't geometry, you know, like the symbol of the spiral precedes all spirals, and in that way, yeah, all fractal geometry, I think, is beyond the visual. We only get the visual manifestation of it, in a sense, just in the way that, you know, the internet doesn't really have a space to it, you know. To put it in any kind of topology is to kind of reduce it in some way. So I think we have to reduce it in order to express it, and that's just the way that reality is. But there are people that apply it to sound and so forward, and do iterative kind of design with music and so forward, and you can apply it to so many information storage and things, like more abstract things as well, yeah.
Thank you.
Cool.
Hello, and thank you for coming here. Just one question. Have you ever tried visualizing it in 3 dimensions and not only 2?
Yeah, you can, depending on, yeah, actually some of the visuals that I did are 3-dimensional. Whether, yeah, there was some there that were and some that were 2-dimensional, and you can do it in n-dimensional spaces effectively. Yeah, you're kind of unbound. Fractals themselves, when we're on the subject, it's interesting, are kind of between, to show you an example, fractals are kind of actually between dimensions in a funny sense, because they're going from one dimension and curling into the next. So in the same way that if this was a perfectly, you know, has rod thickness, if it was actually a 2-dimensional sheet and I did that, it would be kind of filling 3-dimensional space, but not quite. So fractals are kind of between the two. You can go through the fractals from the 2nd to the 3rd, 4th dimension. So yeah, you're kind of unbound.
Hi, don't know if this is going any too far, but can you maybe say something on the concept of entropy? Considering order and disorder, and especially, is there any kind of entropy to fractals?
Wow, yeah, this is a very, very good question. So for those that don't know, entropy is it's normally described as disorder in physics. It's basically the tendency for systems in physics to become less and less organized, to spread out and become warm, fuzzy bodies. What it means that was kind of its classical description. What is very interesting about entropy is actually, if you define information, there's a new science of information emerging, in physics, information physics, where we're describing, like I said about entanglement, because we can't say the object is here or there, so where is the information? And this is where you end up in abstract kind of holographic spaces. Information itself is equivalent to entropy. The more entropy something has, the more information it has. So I'm very, very interested in that question, because I'm very interested in the amount of information in these forms. So in one way, the Mandelbrot set has very little information, it just has a singular equation. And in another sense, it has infinite information. So I think that your question pertains to something that would be a whole workshop in itself, but it's a really important one to bring home. It's that the marriage between the two. And somewhere between the two, we end up with kind of the opposite, neg-entropy, so per se, in the form of, say, a human body, where we suddenly kind of, as fractal forms, we have very low entropy. So it's a whole kettle of fish, but it's a good one.
First of all, thank you for your talk. Very interesting and nice pictures. I loved it. My question. So let's assume fractal nature applies to everything in the universe. What if we take something abstract as ideas and thoughts? Do you think that fractals also apply there? And if so, can we observe it?
I'm not sure if we can observe it with apparatus apart from the consciousness itself, but we can certainly observe it from within. So for instance, that butterfly I showed you at the beginning? Well, the Lorentz butterfly is actually defined in a multi-dimensional space, this place called phase space, which is, because in chaos theory we're not interested in exact solutions, more interested in the behavior of the system, because we know that it's sensitive, so it will change. There's no point knowing what it's exactly going to do. So what you do is study the behavior in a multi-dimensional space, which isn't like X, Y, or like left, up, and forwards. It's more like position, momentum, mass, energy, time. And you end up with these very, in chaotic systems, you end up with these extremely beautifully kind of hot, semi-repeating shapes called attractors. And effectively what an attractor is a region in this abstract phase space, which is very abstract because it's not the space that we witness, yet it has a lot of order in it, that attracts events towards it. So events on the phase space diagram, like in the case of the butterfly, are far more likely to happen. It's a bit like pulling the plug out of the sink. So I believe that there's a very strong correlation between that type of geometry and the archetypal forces that play out in our lives. The way consciousness appears to have a presupposed landscape to it. There are certain regions that are more trodden than others, and we might call those stories or myths. That is our connection to a larger, or to a collective psyche, in a sense, is through that kind of, it's almost like the archetypal forces could be modelled with attractors, if that's what your fancy was. Yeah.
Yes, thank you very much.
My pleasure.
I was wondering why an observer changes the way that particles behave as either waves or as particles.
Why would be to kind of describe to you the unspeakable, which is that the Tao that can be spoken isn't the eternal one. We don't know why. We witness a reality that participates with us as we participate with it. So everything that we do, kind of, its state of potentiality is brought into the manifest form when a participation happens. When something participates with it, on some fundamental level, the universe chooses out of a number of possible opportunities for itself what to do.
And I mean, why it chooses itself, or how it chooses itself, is to really ask how the universe is the biggest question of all, really. I believe that the quantum field is foaming with information, it's breathing creativity into the universe. It's my personal belief. And I think that the mathematics is quite close to supporting that. Why? Because the universe is made of love and it wants to express creativity and it wants to show itself in a manifest form rather than in a blurry, constant state of possibility. Maybe that would answer.
Hello. You said that it was your debut. It was a great debut. And I have one question. Have you contemplated, studied link between, for example, parallel universes theory and the fractals?
Yeah, I'm not so much in the bag of the parallel universe. I don't subscribe to it so much. I think that I think it's a bit of a cop-out, because what it tries to say is that everything, because physics can't describe, like, it's linked to the last question. Physicists struggle with the last question, so they're like, well, everything must be happening, we just can't see it happening. The mathematics doesn't really work out for a start. But secondly, I really like to, I'm biased in the sense that I really feel there's this, that free will is a very real thing. I feel very responsible for my life in a parallel universe where all possibilities are happening. Then it doesn't really make a difference because it's happening somewhere else anyway, whatever you do. So yeah, I'm really more leaning towards this holographic description of reality, which seems to really kind of maybe next boom will go down that rabbit hole instead, because I think it would really relate to a lot of the experiences that we have. I think it can be quite experientially received in the body, whereas the very definition of the multiple universe theory is that it can't be. So I go down the rabbit hole of the theories that we can experience we've actually experienced, yeah. But each to their own, that's the point, is we're writing our own myths and we can write whatever myths we want. It could be a teapot, like I said, It is a teapot, in fact. It's definitely a teapot.
All right, thank you so much,
Thank
Jamie,
you.
for joining us here at Boom 2014 Liminal Village.